The deputy is Daniele Ciani. Here is a short, non-exhaustive list of key personnel. As a reminder, Mark Worsfold will be our Ocean State Report and OMI expert. Joanna Caragali for the product quality as a product quality expert. Bruno Bongiorno Nardelli and Emanuele Tre, scientific expert. Flavio Lapadula, technical manager, and Jean-François Piollet and Vega Forneris as DTO experts. Next time I will put some pictures, much better. This stack is the element of the Copernicus Marine Service in charge of the provision of operational SST products for the covering the global ocean and the European regional seas. They are provided as near real-time data and multi-year, the latter suitable for climate application, and available as merged multi-sensor, level 3S, and level 4 data. The catalog at the start of phase 2 will actually presently includes a total of 27 products, 14 near real time and 13 multi-years, plus 12 SST OMIs. Of course, the catalog will evolve during the contract period, and basically there will be a new product and a rearrangement of the global products within the catalog. I'll show something later on. How the SST TAC is carried out? Well, as I said, we are 4 production units. CNR is in charge for the Mediterranean Sea and Black Sea products, DMI for the Baltic Sea, Ifremer for the global and Atlantic products, where for Atlantic, I mean EB plus Northwest Shelf, and Met Office for the global ones. Each production unit is responsible for its own production, from the ingestion of data, input data, up to the final delivery of their products, but also is responsible for the documentation, PUM, QUID, and so on, and the routine product monitoring. I really do thank the Meteorological Norwegian Institute, which has been acting for almost a decade as our local service desk. Thanks to their efficient work, the flow of information between the central service desk and the 4 production unit run always smoothly. Concerning the evolutions, well, the overall objective is to guarantee a continuous evolution of the SST TAC products by incorporating advancing technologies and scientific innovation, and at the same time maintaining the SST processing chains up to date, for example, by integrating new satellite sensors. Our attention is also dedicated to the user's request, both in external and internal, and try to integrate these requests into our evolution. Concerning the near real-time production, well, artificial intelligence and ultra-resolution coastal mission are among the most challenging evolution plan for this phase. AI, we aim to enhance the existing optimal interpolation techniques by including deep learning methods such as 4D-VerNet, with the aim of improving feature resolution and overcome the limitation of OI algorithms. These evolutions are planned for the Baltic Sea and Odyssey products. Another important mission for us will be the exploitation of ultra-high resolution SST data from current missions such as EcoStress and Landsat, and the future ones such as Trishna and the Copernicus LSTM mission. So the aim is to perform feasibility studies to improve the SST characterization nearby the coast and potentially release coastal beta products. And as new products, we plan to reintroduce the GRIST multi-product ensemble, also called GMP product. This provides mean and standard deviation maps built from an ensemble if I remember well, 10 global SST products, and can be very useful for intercomparison exercises. Moving to the integration of new sensors, well, this is the list of our plan sensors. For sure, Sentinel-3C planned for the 2027 in both global and regional products. NOAA-21, which is the successor of NOAA-20, planned for this year. The integration of MTG, the Meteosat third generation, which is the successor of Seviri. And another important evolution, challenging evolution, is the integration of passive microwave data from AMS-TRU into the regional products, such as the Baltic, Mediterranean, and Black Sea. This is a preparatory study for the future CIMR mission, the Copernicus Microwave Mission. Multi-year production, well, the SSITAC will ensure the regular temporal extension of both regional and global products. This year, we plan to reintegrate the operational production of Ostia REP, which is currently frozen due to Brexit. Also here, we plan to integrate passive microwave data as available from the CCI CDR into the regional multi-year products. And there could be a possible replacement of Ostia REP with a new version based on CCI level 4 data. These two products are quite similar based on Ostia algorithms. So the aim is to convert the CCI level 4 data, which provides an SST at 20 centimeters, into a foundation SST, thus aligning with Ostia. And a full reprocessing based on ISA CCI version 4 is planned in 2027 if the new version is available. An important evolution for the catalog concerning the global products will happen in June 2025. It is mandated that only one global level 4 near real-time product and one global level 4 reprocessed product shall be maintained available in the catalog. So we have basically two families of global products, the Ostia and Odyssey families. Now the choice on which products will remain in the catalog will be based on a dedicated studies led by CNR. However, the other two products will be, the production will be continued and updated into the MDS, but kept non-public. Of course, to avoid impact on users. Concerning OMI and Ocean State Report, the stack will ensure the temporal extension of all the SST OMIs. We plan also to improve the uncertainty estimate, to provide intercomparison data, and in this regard the new GMP product can be useful, and to deliver Python notebooks for each OMI. The SST will also contribute to the annual Ocean State Report as done in the previous phase, where, for example, last year the SST contributed to 3 sections of the 8th OSR. A few words about cross-cutting activities and clauses concerning product quality. We will contribute to these activities. Currently, we will continue the delivery of the so-called level 3 metrics, and I mean, we are open to the development of new metrics. As anticipated by Pierre-Yves, the C3S clause has started. The SST started working on this proposal involving 3 institutions to ensure the continuity of the SST CDRs and ICDRs. The institutions involved are University of Reading, Met Office, and DMI. Yeah, and of course we will give our support to the other 2 clauses. To conclude, a big, big challenging evolution are the exploitation of ultra-resolution mission and integration of passive microwave data. Thank you. That's all from my side.
Thank you. Thank you, Joe. We will have a question on Slido. I think that now it's also possible to answer question from the audience, or the leader or deputy that will be targeted by question can also answer now and in the coming days. I have just a curiosity. You mentioned EcoStress a couple of times, but then I didn't see it in your table with the future mission. Are you going to make use of this mission?
To integrate EcoStress?
Yes.
No, I don't think so, because EcoStress and Landsat are not operational missions, and are data are quite noisy, so not usable in an operational product, but very important to test and prepare the assimilation for Trisna and the other missions.
Okay. Okay, thank you. So we move to the next presenter, which is Vittorio. Welcome, Ocean Color TAC.
Also, good morning, everyone, and I'm going to present the organization and plans for the Ocean Color TAC for this next 3 year and a half. Mainly, the Ocean Color TAC has the role within the Copernicus Marine Service of making sure that we bridge a gap between the space agencies providing a series of standard products and the users making sure that we do the best to produce products both for the global ocean and for European regional seas using as many satellite ocean color mission as possible. In this moment, we are providing a large set of essential ocean variables that can be retrieved by ocean color, going beyond the chlorophyll, which was what we were doing in in the past, but having added also optical properties, information about the phytoplankton, functional gap and community structure, and primary productivity, and so forth. The important work that we've been doing in the last 10 years within Copernicus has been to ensure that we not only have this high level of observation products, but we also add value to the standard product by the agency. The main way how we do this is by making sure that the regional products are more accurate at basin level than the standard products delivered by the agency, thanks to the regionalization of the processing chain that takes in account the variability in the bioptical properties within among regional seas. The new consortium has been expanded compared to the previous slides, and in this moment we have 3 production centers with ACRI operating the global and the Atlantic production chains. At CNR we operate the other 4 regional processing chains, so Mediterranean, Baltic, Black Sea, and the Arctic. And then we have Brockman together with Arbins providing the high-resolution processing chain at 100-meter resolution for all the regional seas, as well as the global multi-year product within the C3S activities. We then have a series of contractors, and they've changed compared to the previous organization. This moment we have HiGeos, Now System, and Equora that provide support in the research development activities for the development of processing chain. We have PML, the Plymouth Marine Laboratory, that at this very moment, as of today, acts for the upstream for the Baltic multi-year, but will become, as part of the 3CS clause, the production of the C3S Ocean Color CCI production. And then we have Laser Roma and Innuere providing support to the project. Now, this is the overview of our product, our product in the catalog. We have 38 products, 214 datasets as of today, based across 3 resolution, multi-sensor at 1 kilometer or 4 kilometers, the Sentinel-3 data as at 300 meters, and the Sentinel-2 data, so the high resolution 100 meters. So we have a variety of algorithms. We strive to have continuity in the algorithm processing chain across resolution and across sensors, and there is quite a lot of detail in a paper that got published last year in December, so last month, where we tried to describe all the evolutions that we carried out since 2015 within this framework. Very briefly, and this is a slide that most of you have seen in different moments here. What we do, as I said, is that we have different algorithms and different processing chains for each of the basins to make sure that each of them are adequate to develop a regional products, and that's why they are marked here in different colors for the different basins. A summary of the validation metrics for all the chlorophyll datasets in our catalog is provided in the paper that I just alluded to. The same here is for Olci, and for instance, there is a difference in which global algorithms is used in this moment between Olci and the multi-sensor. For the rest, all of the other are the same, and again, they are details important to show. We also have, as I said, phytoplankton size classes, phytoplankton functional type, and the most new recent addition, which were added in 2023 or 24, are the primary production for most of the basin, going one by one. And so here there is again an overview of all the algorithms. They differ, and there is some continuity there to be seen, and some of them are going to evolve, as I'm going to show you in the next couple of slides. Then we have what continues to be our youngest set of data sets, the set of products. It's been in the catalog only since 2020, but is a high resolution product, 100 meters. The data is available every 5 days, a very high resolution, and there is both the remote sensing reflectance and suspended particulate matter and best scatter and turbidity, as well as chlorophyll. Now, going through very briefly, just a very quick introduction to the evolutions, then this information is provided in full details in the posters, so we will have a chance in the next few days to show you and highlight in very detail what we will do. The main important point is that in the first task is about uptake in new input satellite observation, particularly in our multi-sensor approach. So the first things planned for 2025 was the uptake and introduction of Sentinel-2C, which we thought would happen later in the year. It happened already a couple of weeks ago, so we already did something which was in the plan. That's amazing. And the other important activity, so we will continue to uptake the Sentinels 2 and 3, and 2C and 2D and 3C are likely to happen in this, within the time frame of this contract. And also we are focusing on the uptake of the hyperspectral sensor launched by NASA last February, which is PACE, OCI, and so quite a lot of work is going on in the uptake of the potential of PACE for inclusion in our multi-sensor, and see what we will do and how much we are able to use it. So most likely that's activity happening 26 and 27. Then clearly the idea of I'm not even thinking you're going to see, this is just a snapshot to see what goes along the three columns in terms of to guarantee the state of the art, the Ocean Color product, both at global and regional scales. There is going to be a continuous improvement of the chlorophyll algorithms across all basins. So for the global ocean, there's going to be an update of the OC5, which is the basic algorithms, which is meant to occur in the next few months. Most importantly, the Atlantic will see a change in the way the product is designed, and this is being redesigned to meet the OSPAR reporting needs. So that's a very important uptake of the user needs, and this has been really brokered by Mercator in the last few years. Looks like it's going to happen. We've been talking only for 4 or 5 years about it, so slowly but surely. Then again, in each of the basin, we are trying to improve as we go, to try and improve the accuracy at each of the basin. We are looking at also in updating all the phytoplankton functional type, and reprocessing of all the multi-year time series will occur either in 26 or in 27. Then another important task that we have was the uptake of the Copernicus Marine Service Evolution projects, ended in 24. So in here we are adding a multi-resolution product that puts together the data at 200 meters, 100 meters from Sentinel-2, and the data at 300 meters from Sentinel-3, and the multi-sensor at 1 kilometer. And this is an uptake of the MultiRes project. Then we are adding 2 new essential ocean variables, being the particulate and dissolved organic carbon for all the basins. We, as I said, we will update the phytoplankton functional type algorithms by using the outcome of the GLOFITS evolution project. And then we are doing something which was developed in-house at CNR. We are changing the way we are providing the gap filling level 4 for the regional products run by CNR, by doing first a gap field, remote sensing reflectance field for all the bands, and then retrieving the algorithms, retrieving all the data sets and product. In terms of preparation for future mission, as I alluded to already, we are looking at the uptake of PACE mission in our data streams, and we are doing this one not only as an uptake data stream, but also to start the preparation of the operational Copernicus mission CHIME hyperspectral, which is due to launch in 29, I believe. 30. One of them. Also, another activity that few of you may have remembered has been lingering in our evolution table in the last few years. We are going to uptake the Ocean Color geostationary data stream from Meteosat 2nd and 3rd generation, and that's as outcome some effort that some of the members of our consortium are currently doing with EUMETSAT funding in a EUMETSAT product. And Hopefully, by 27, the product will be operational in EUMETSAT, and so we can pick it up and uptake it in our catalog. So, thanks for your attention.
Thank you, Vittorio, and thanks for being in time. I have just a little curiosity. You mentioned an update of the Arctic PFT product.
Yes.
I was just curious what...
So in this moment, we have been updating the chlorophyll product, and the last time we made an effort, which was last year, we really struggled in finding enough validation data to understand whether the original product could work for our multi-sensor. The hope is that given that we have the GLOFITS project coming along, having finished, and the new project again, which will be presented tomorrow or the following day, I don't know, by Ongyang. So the hope is to be able to pick it up, that one, because in this moment we don't have an Arctic PFT data set. So we need to,
requested.
you know, but because our retrieval were such that did not deserve the disk space. That's really what it is.
Okay, thank you. Thank you. Okay, so we move to Dominique, which will provide us an overview of our in situ thematic assembling center. Please, Dominique.
So good morning, everyone. So I'm Dominique Aubaton. I work at IFREMER, and I'm going to present you the InstitutAC. So I work at IFREMER as the leader of the InstitutAC, and on the picture you also see Stéphane Tarot, who is the deputy of the InstitutAC. So we are a big consortium of 16 partners and from 9 countries. And several of them are in the room, so you will be able to talk to them if you want. So in a quick view, so we are the leader at IFREMER. We have several partners that are responsible of one of the region to deal with the data, which are either the physical data, the biochemical data, or the carbon data. And we have additional partners that are responsible for the multi-year parameters, the multi-year product, and of the parameters, and experts of some parameters, and are also involved in the different cross-cutting activities of the InstitutAC, and in collaboration with Mercator, of course. So the data sources, they are multiple. They come from many, many different platforms. In different places in the ocean, by the coast, and also, of course, also in the deep ocean. And what is important is that InstitutAC doesn't own the data. So it's, we can see InstitutAC and of course, what we do for CMEMS as a data integrator. So it's data coming from different various sources. So these sources are at a national level, are taken at a national level, also by our regional experts that are involved in the different countries and different institutes, and go to different institutes to get the data, at the European level and at the international level with different networks of these different levels. And the data flow is vary from one source to another one, and we try to manage to have them in InstitutAC. And we have a lot of work on the duplicates to avoid to have 2 or 3 times the same data. So the portfolio of what we propose in the Copernicus Marine Service. So in terms of MyNRT, so the multi-year real-time product, we have mainly our products are organized by region. So we have a global product and product for each of the 6 European regions. So it's 7 altogether, it's 7 regional products with most of the variables, so most of the parameters. So we have in this product the physical variable and the biochemical variable, except for the UV, which is a bit more different and complicated. So we have a UV product at the global scale, a UV global near real-time product. And in addition, we have one product which is gridded. It's the TSOA product. Because I didn't say, but the other one, they are at measurement points, so that discrete product. In addition to these 9 products, we also have 2 internal near real-time products, 1 TS and temperature and sanity, and 1 current product at global scale, which are optimized and used for assimilation purposes. For the portfolio concerning the multi-year product, so they are organized in a different way than the near real-time one. They are organized by parameters or group of parameters. So we have one, and they are all of them global products, but it doesn't mean that we go of course to the coast and to each of the European region. So we have one temperature and sanity product, 1 current product, 1 wave product, 1 BGC product, 1 carbon product, 1 sea level product. And in addition to that, we also have a gridded product for temperature and salinity. And then we also have 12 OMI from the extreme event family. So we have the temperature, the wave, the height of the wave, and the sea level in 4 regions: Baltic, Norway Shelf, EB, and the Med Sea. So now I go to the evolution that we plan for this contract. So our proposition and answering to the requirement from Mercator. So I start with the near real-time, my NRT part of the product. So in 2025, we are going to simplify our product, and by removing a directory of some of the files that we have in other directories. In 2026, we have a big something important to do is that we are going to remove our regional near real-time product to have only one global product that will be built by all of us, and with especially the expertise of the regional partners to ensure the link with the providers and for the expertise on the area. And in 2027, we also want to work on this UV product to have something better organized and simplified, both on the data management side and for the user to take and to work with the product. So now I go to the evolution of the catalogs for the multi-year product. So I start with the temperature and salinity product. So there are lots of work on this, on the product, the not gridded one and the gridded one. And it's a continuous work and improvement with Mercator. We have some issue on the data itself, but we are working on now. But it's reducing and reducing, so which is nice. In next year, in 2026, we plan to have an update of the first guest of the method used to have a gridded product. We also plan to have the improvement of the min-max method, which is the validation method that we use for the temperature and salinity. So we have 2 versions, one for the near real-time product and one for the multi-year product. And we plan to have a comparison and to explain why we have this and this and this in each of the methods if useful. And there is also an improvement of the near real-time method that is planned in the following years. And for all the multi-year product, we will have regular update during the contract every 6 months, and also reprocessing. So it's written on each on the slide, but I'm not going to to tell them again for each slide, for each parameter. So the second family of parameters for the multi-year is the evolution for the current. So actually, the main evolution which is going to lead to the system evolution. It concerns the drifter dataset. So in 2025, we will have more data put in the dataset. So it's nearly 15,000 drifted that will be added. In 2026, we will improve what we have done by working and proposing a method to be able to take account on the buoy and the data that have a drag loss. And then in 2027, we will add the temperature along the trajectory, which is an hourly temperature. For the wave product, so still the multi-year product, in 2026, we plan to have the inclusion of the wave data from, let's say, a new platform for wave. It's this tide gauges, so it is something we have going to start to work on in 2025 to have something which will be in operational. So in addition to the buoy, which is the main information for the wave, we will have the tide gauge in 2026 in the catalog, in the same product, so it will densify the product. And then by the end of the contract, we also have the inclusion of the wave taken from HF radar. So for that, we need some work within an internal system evolution within InstituTAC. And it will be done in two steps. First, the data will be harvested in the near real-time product, and then the wave the multi-year product. But this will be done for some pilot sites. Then for the BGC evolution, the BGC product. So in 2025, we will add a data set, an easy BGC data set. So it will be a chlorophyll 1 based on the model that we have for the already for the oxygen. And we also plan to extend, so to have something easier for the user to use using the same unit, for example. So we plan to do that year by year. And an important point is that we also plan to merge the carbon product into the BGC product. So this means that we will have all the carbon data that we have from SOCAT, GLODAP database, and other sources in one single data set that will be added to the current BGC product. And the gridded field that we have from SOCAT and GLODAP will not be longer available, but we will tell the user where to get them. And so this means that we will have a data flow which will correspond much more to the other product that we have in our catalog. So we go to it's going to be more homogenized. Our offer will be more homogenized. And then in 2027, this min-max method that is applied for the temperature and salinity will be applied for the oxygen to see how we can better validate our data, our product. For the sea level, so this year and next year, we already propose a data set including tide and surge, and this is only for the EB region for the moment. So in this year and next year, we propose to extend this data set to the other region of European region. In 2026, we will include the land motion correction, vertical land motion correction, within the sea level data set and sea level product. So for this, we have many additional work to do. And what I forgot to say is that in our consortium, we are now 60 partners. At the end of the previous contract, we were only 15. And our new partner is Université La Rochelle, who is going to work on this GNSS vertical land motion correction. And then, before the end of the contract, we hope to have the GLOS network, which is an international network of sea level, fully or nearly fully integrated in CityTAC, in the sea level product. So this has started in the previous contract. It was a bit complicated, and with especially with to have a clear and easy way to work with GLOS, but now it's working and it's going bit by bit. So each year we will continue to integrate the data from the GLOS network, and we will increase and improve our collaboration with the GLOS community. Okay, so Antonio talked about that a little bit when he introduced the different TAC. So one important point is that, and we are requested in the statement of work, was to add the ICE parameter within CityTAC. So for the moment we have physical parameters, but we don't have ICE. We have temperature, salinity, wave, sea level, and current. And to add ICE so this is something that we can do and we are going to do. This is completely new. So first we have to identify the data source from the different basins, the Arctic, the Baltic, and the Black Sea. Then we will have to establish the metadata standard and the vocabularies, so it will take some time for the 4 parameters that are requested: thickness, type, drift, and concentration. And then we, of course, will have to build and implement the QC procedure for this data. But at the beginning, we'll be harvested in the near real-time product, so it will be near real-time data and near real-time product. And for a multi-year product, we will see in a future phase. It's not possible now. And in this first ICE data that we are going to add, we do not include Antarctica because we have more data and it seems to be more easy first to concentrate on the north part. Okay, now I go to the OMI. So for the OMI in 2025, we are going to add the uncertainties to the 12 OMI extreme events that we have in our catalog. And we also would like, but it depends on the process, the review process acceptance of Mercator. We also plan to have, we'd like to have some nutrients proposed in the Nordic Sea. So these OMI, this could be an OMI. There is already a text in the Ocean State Report number 5. We also would like to propose a multi-approach OMI using what we have as SST extreme events by adding EBMFC for these SST extreme events. So it will be a multi-approach with in situ and EBMFC. For 2026, we plan to have an ocean in content OMI, also based on what has been already written in the previous Ocean State Report. And in 2027, but this will also need to have a contribution to Ocean State Report before, so next year. We plan to have an OMI on deep convection in the North Sea, I think. I'm not sure I remember the right area. And then the last slide. So in addition to all this, we have we are going to develop, we are going to work on 2 QC methods based on AI. So the first one, which will be the output of the service evolution which service evolution project, which is called IEQC and which is led by IMR. And there is an operational part that will be taken into account in INSTITUTAC for some regions that are not considered in this project, which is the Arctic region. And we also have, we'll have a prototype of improvement of QC for near real-time current based on HF radar. We also plan to work a lot on metrics and KPI within this contract. For this, we have already set a new intercode working group to work on the product quality dashboard that is requested by Mercator, but also to work on internal monitoring for our own product. And the last point is about the Western dashboard. So we have developed several years ago a website to be able to visualize the in-situ data. And we are going to continue that in a complementary way to what is done on the Copernicus Marine website, and especially thanks to the MyOcean Pro. And especially, this is an important point for to have the catalog of our providers. And that's it. Thank you very much.
Thank you.
Yes. I forgot to say, if you have any questions and so on, we will be very happy to answer about them, especially during the poster session.
Yeah, on Slido again, we will have time. And tomorrow I saw already, I have also some question about your quality control based on AI and KPI.
Okay.
We will have time to discuss tomorrow. Thank you again for detailed. And last but not least, we have the multi-op stack. It's a kind of special tag. They do a very interesting and quite successful job. They integrate data from different tags to produce higher level data. I will leave Hélène explain us what are the plans for the next 3 years.
So hello. So the multi-observation tag is based on observation and satellite and in situ and data fusion techniques to provide some products that takes advantage of the goods and stay close to observation. And this is a complementary approach to model or assimilation from the MFC. We are 7 partners in the consortium. For this phase, Datlas has joined us. So we have 9 products and 1 review close product, which is sargassum detection. We have 6 blue ocean products, and with 4 NRT products and 3 green ocean with 2 NRT, and 3 OMAs based on carbonate variables. Just to present you people, so CLS is in charge of the management of the TAC and in charge of 2 products of physical variables, Armor 3D for 3D physics, and Copernicus globe current, which are surface and 50-meter currents. CNR is in charge of Omega 3D vertical velocities and sea surface salinity and density. IFREMER is in charge of the L3 SMOS SSS and L4 SSS, combining SMOS and SMAP data observations. And Datlas will provide some new variables to the Copernicus globe current products, including high-frequency surface currents. For the green team, we have LOVE and LSCE. in charge of the Canyon products, nutrient and carbon profile, and SOCA 3D, which are 3D BGC, and Copernicus surface carbon from LSCE, which is the product on which the 3RME on mice are computed. So for the evolution, first, all the SMOS SSS products will be reprocessed based on a new version of ESA L1B products, and it has started last year with a new processor baseline. So during the reprocessing period, the catalog won't change, and when all the reprocessing will be available at ESA, we will shift to this new reprocessing. So this is, we don't know exactly when, but probably in 2026. So there will be a major release of the L3 SSS products. The SSS L4 will also, which use the SSS L3 products, will also evolve with a major release in 2026, and a new version also of the mapping will be released with a new time window for the mean SSS, and with a new L3J products that will be clearly denoised compared to the previous version. Regarding Omega 3D, so vertical velocity, at the end of this year, a new NRT product will be set up. So the product will change into my NRT product, and a new dataset will be included. And in November 2027, a new high-resolution processing of this product will be set up, with an increase of resolution from 1/4 degree to 1/8, and daily resolution instead of weekly resolution, to be fully aligned with the Armor 3D upstream used by Omega 3D. And a new processing chain will also be set up using AI methodology to improve the time, the computation time, and methodology. Regarding SSS SSD product, the upstream will be updated using SSS L3 from the MOBTAC for the SMOS data. In input to the SSS SSD L4 processing, and there will also be an update of the product frequency. By the end of 2026, there will be an upgrade of the products with an improvement and a full reprocessing, with an improvement over the Arctic, with a new selection of the data to be optimal and to reduce the error, the interpolation error in the Arctic, and a new background SSS that will be chosen from some entire comparison of the SSS products. Regarding Armor 3D, 3D, the first big evolution will be at the end of this year with an increase of the temporal resolution from weekly to daily and an increase of the frequency from daily to weekly and spatial resolution from 1/4 a degree to 1/8 a degree. 3D uncertainties will be added also in a new data set, and some update of the algorithm will be released with a new selection of the TS profile at the surface and a 3D error propagation. In 2026, in June, new variables will be added. Marine heat wave categories will be added to these products, and a major release will be made in 2027 with a major upgrade of the methodology, focusing on the OI to be replaced by a variational approach for the correction of the 3D velocity and the use of the deep Argo velocity to extend correction of the velocity to 2,000 meters instead of the 1,050 meters. New variables will also be added in the My dataset at first with the 3D Ekman spiral, completed by Stokes drift and tidal currents. Some studies are ongoing in the Med Sea, and we hope to escalate to the global ocean products if the results are good enough. Regarding Copernicus Globe Current products, the first evolution will be held in 2026 in June with a major upgrade of the spatial resolution from 1/4 to 1/8 degree. Again, to align with Armor 3D and try to have a consistent MOBTAC catalog in terms of resolution and frequency. We will add the Med Sea to this product, which is not the case at the moment. We will update the Ekman parameters. So we probably update the empirical method or try to use some machine learning methods. And we will add new variables, Stokes drift and the relative uncertainty using Higgins 2020 methodology. For the 2026 release. In 2027, we will add new variables, the hagiostrophic current from unsteady Ekman current, from the expertise of Clément Hubelmann at Atlas, which will be the legacy of the work project. So we will have real high frequency near inertial hagiostrophic current in the surface current, surface and 50 meters current. For the green ocean products, for surface carbon, we will have a full reprocessing each year. But the major evolution will be sub-monthly update and update of predictors for coastal area. So using new predictors in the coastal area and specifically near coastal upwelling or river discharge. We can update the predictors and get more accurate value of the carbon variables in this area where the errors are important at the moment. Regarding nutrient profile of carbon, product unit will change this year from LOF to CLS. And the full reprocessing will be made available in 2027 with new in-situ TAC, with new upstream from in-situ TAC. So from the upstream will be, or actually taken from JDAC and will be shifted to in-situ TAC Argo. And SOCA, for SOCA 3D products, by the end of the year, light variables will be added with 3 downward irradiance at 3 different wavelengths. And by the end of 2026, PFT will be also added with 3 functional tip at corresponding to 3 different size of the phytoplankton. By the end of 2027, there will be also a full reprocess with probably new upstream from the BC Optic service evolution project which is actually ongoing. And we hope to get some cleaner and better upstream for the SOCA 3D products. So here is a general overview of the product, and that's all for me.
Thank you. Thank you very much, Hélène. So I'm sure there will be question for all the variety of products that you have. So you can leave question on Slido. We will answer. It's time to break. We have 1 hour and a half, so we will reconvene here a bit before, I would say, 2 o'clock. You can leave things here. Vincent just told that will be closed or secured, the door. For the lunch, the restaurant is downstairs. And lastly, there are plugs here for your laptop or some other downstairs if you would like to. And at the back, over there. So see you in the afternoon to continue with the MFC. Thank you.